everybody and welcome back. Hi everybody, welcome back. My name is Samira and today we're going to be going over my CS110 project, which I'm going to be constructing 3 different patterns into one base. And so this is my base right here. It's a hexagon with like squares and triangles. This is my maze pattern. These two right here are my patterns as well. So to do my first one, I have to import turtle. Turtle.tracer basically like draws the turtle fastest. I come up with the function spiral underscore 1, test size and colors to draw the first maze design. Then I assign size divided by 25 into size. Size times 0.5 to delta, so it can create like it can make the squares bigger and bigger each time. Then I do size plus and equals delta, and then I infill, which means I just let Tess put the color in. And so for this one, I make another function, which is depth spiral. Test out size basically makes the first spiral. Then I assign size times 0.5 to delta. And then I make fine range 7 because I'm making a row. So I do backwards 7, left negative 90, size plus and equals delta. Then I let Test draw it, and then I make another one to make the second design, depth spiral 2, test, and test and size is make the second square of the square spiral on the top. Then size times 0.5 is going to be assigned to delta. Then I do fine range 7, which is again the row I'm going to be making soon, and t dot forward size, and then t dot right negative 90, and then I assign delta, then size plus and equals to delta, and then I make another one which is then here right here. Then it's called keep g test and size. This makes I use this as a helper function, pen up backward size times 2.5 right 90 and forward size. So to make the bottom half, I do depth backward test and size to make the bottom half. I said fine range 2. I use this as a helper function, pen up forward size times 4.5, left 90, forward size times 2. Then I do left 180, so I can because this one and this one is like just shifted by 180 degrees. Then I do bend down. I let Test draw it, and then I make another function, depth turn, angle, test that size. This makes another pattern, but opposite. T dot left 90, then I use this as a helper function. Then I let Test draw it, and then depth turn, angle, row 2. This makes a pattern of rows, which is right here. And then I use this as a helper function, backward, test and size, pen up, forward size times 7.5, left 90, backwards, size times 2.5, right 90, pen down. Then turn angle, again, pen up, right 90, forward size times 4.5, left 90, forward size, right 90, forward size times 2, pen down, and I use this as another, I just let Tess draw the whole thing. And so for this one, I make the entire design. So I do depth, turn, angle, row up, test, size, and colors. This continues the pens horizontally and vertically facing up. I fill in the color, which is, I just basically put in the color I want, begin fill, size. Size is going to be assigned to 21, pen up, right 90, forward size times 2.5, left 90, forward size times 2, pen down, turn angle, row, which is another helper function, pen up, forward size of 2.5, right 90, forward size, again, 6.5, pen down, left negative 90, then turn angle, test and size, pen up, forward size times 5, left 90, backwards 9.5, pen down, use this as another helper function, test dot size up, pen up, backwards 6.5, right 90, forward size times 2.5, left 90, pen down, turn angle, test dot size, t dot pu, backwards, size times 4.5, which just goes backwards and this draws the entire thing, and then pen down, then turn angle, test dot size, pen down, and then forward size times 5, left 90, backwards, it just draws this entire design. And so for this design, because it looks like this, I start by drawing a rectangle, and then I fill in the color, begin to fill, use a for loop, right range 2 forward, W left 90 to make the actual shape, forward H left 90 and fill, and then I let test draw it. Then I use another helper function, and then I make another function called def row stripes, which then makes a new row of stripes. Use a for loop. Then I used it as another helper function from before. I put 10 up, test up, forward W, and then I use this draw underscore rectangle again as another helper function, pen up, forward size, pen down, and I let test draw it. And then this constructs the entire shape right here, the entire shape and design right here. So then it returns a row of space between rectangles. So I do for I in range 5 because it has 5 rows. Then I do row stripes, test WH color and another color, pen up, forward size W times 2.5, pen down. Then another helper function draws row of rectangles horizontally and vertically, and then I use a for loop, find range 5, space, underscore rows, another helper function, pen up, backwards 32.5. This basically helps me make sure they're in place. And then right 90, forward 2.5 times width, plus H, left 90, pen down, and then I let test draw it. And then this one basically I'm trying to like construct like a single hexagon shape right here. So then I just make a simple hexagon shape by calling in the function for that and adding color because I wanted to have color in the middle. So I fill in the color with purple, but in this case I call it colors. Then I start to begin fill, and then I use find range 6 because it has 6 sides because it's a hexagon. Then I do forward size. I go right 360 divided by 6 because this is the turn angle. Then I end the fill, which is like I just color, and then I let test draw the hexagon. Then I do to make the empty squares, I make a simple square function. So I do def square size, test and size, draw the square that can be used to draw outside of the hexagon. Then I use for I in range 4, forward size, left 90. I draw the square, and then I draw empty squares on each side of the hexagon. It's a for loop of 6, pen up, forward size, right 90, pen down, and I let test draw it. And then this one basically constructs a single triangle, which I'm going to be explaining in the next slide, which draws a single triangle, fill in color, to begin fill, find range 3, forward size, turn angle, and end fill. And so this one I basically, so in this slide right here I combine patterns 2, 7, and 21, which I've explained before. And so I make a function. This basically draws a triangle on each side of a hexagon. It combines every single code together. So I use empty square and hexagon as empty function. X and Y is basically like a position, so I can position the my designs and the triangles, so then it doesn't so it does align with each side. So I do for I in range 3, left 90, triangle, test out size, colors, and fill, pen up, right 90, forward size, right 60, pen down, left 90, triangle, color size, TED. This basically like fills in the colors for the triangle, and also for the other designs too. And for this one I do so to put in every single shape inside of my hexagon, I do pen up, left 90, forward size, right 90, pen down. And so this one basically draws the first one, and then this draws the second one, and this draws the third one basically. So then it just combines one side, and then the other one it combines the entire sides, which I do T dot left 90, pen up, right 60, forward size divided by 1, right 90, And then, so basically the turn angle rows up is basically this design right here. The spiral 1 is right here, and then the row of rectangles is right here. So basically I constructed it so then each and every of them are aligned with one of another, and so I just so for this one I did left 90, a pen up, right 60, forward size divided by 1, right 90, and then I test draw the function, and then I do pen down, pen up, right 60, forward size divided by 2, t dot left 90, forward size, pen down, I draw this function right here, which is this one, and then pen down, pen up, then go to, because this right here, like, it wants you to like draw them at the corner, and so I position it at like a corner so then it could draw each and every rectangle by on its own. And so I did a left 30 backward size, left 90 forward size, minus h, t dot right 90 pen down, and I just draw the row of rectangles, which is right here. And yeah.